Hi, greetings nerds. This is a talk about Salt plugins, which are not typically seen or known about. My name is Mike Place. Some of you may know me online as Cashed Out. If you were a SaltStack contributor who has sent pull requests, I'm that guy. Hopefully I've been very nice to you. If I haven't, now is your chance for revenge. So, with that, I run the engineering teams at SaltStack and help to manage our open source project. And I like to begin every talk, everywhere I go, with saying something that I'm really serious about, which is thank you so much for your work and your participation in our community. It's incredibly humbling to me, to the people that I get to work with every day, and it's just incredible to be able to work with some of the smartest people on the planet. It's humbling and it's hard to get to read code every day. And sometimes I'm like, I need to go take a walk because that was so smart, I'm not even sure what to do with myself. So thank you so much for your work, and whether it's code or filing issues, I want everybody to know that we actually get really happy when issues get filed. We're not happy that bugs exist, we're not happy that issues exist, but we're happy that you care enough about the work that you do and your participation in SALT to let us know and do the work that it takes to follow those issues through to completion. So, with that, excuse me, okay. Like I said, this is a talk about the lesser known parts of SALT. And for those of you who have been to a SaltConf before, I have in fact given this talk in the past. I did make slides, and I have thrown them all away. So if anybody really wants slides, I will be happy to send you my slides from 2015. But outside of that, I just thought I would walk you through some of the parts of SALT that I feel like people don't pay enough attention to. And hopefully it will give you some ideas about how you can use SALT in ways that you might not have thought about, or how you can use different components inside SALT to solve problems that you might have day to day. Now, I've been working on the SALT project for about 4.5 years, almost 5 years now. And when you sit down with Tom, one of the things that will probably come up as you really start to talk about SALT architecture is our belief that SALT must always continue to be fundamentally a pluggable framework, right? We believe strongly in the paradigm of pluggability, of separability, and of separation of concerns. You know, I come from an old Unix and Linux background. I'm an old graybeard. I believe strongly in the Unix philosophy, and we try to work hard every day to incorporate that into SALT. And so as you use SALT every day, I'm sure you've encountered some of the pluggable systems, maybe not even realizing that they are in fact pluggable systems. Certainly, most people start out when they use SALT, they use it for remote execution, right? Like, I want to be able to do a thing on many machines, and okay, I'm learning SALT, and there are these sets of commands, right? And eventually you figure out that these sets of commands, things like command.run or service.start or things like this, are all part of what we call execution modules, right? And then you might learn about states, for example, and you see that there are states. And so you go into the states directory and you look at all of those, and life is fine and good. And many times that's where people's knowledge about SALT's pluggable systems starts to come to an end. Does anybody have any idea how many pluggable systems there are inside of SALT Core, the version of SALT that we ship every 6 months? Anybody want to guess? If you've been to my talk before, no guessing. A dozen? Somebody said a dozen.
About 300.
About 300. No, it is not that. I think the guess that you're making is the number of distinct modules, which is not the question that I'm asking. I'm talking about pluggable subsystems. So states would be a pluggable subsystem. Execution modules would be another subsystem. Any other guesses? Somebody guessed a dozen? 12? No. Did somebody say a billion? Is it one of my engineers trolling me? Because I do have tasks to do, so I wouldn't do that. About 10, no. The answer is in the mid-30s. There are about 30 pluggable subsystems in SALT. Now, some of these are really obvious, others not so much. Oh, whoops, okay. So one of the easiest ways to start to think about this notion of pluggability is, can everyone see this okay? Are we cool? Bigger, bigger? All right. I feel you. How about now? Better? Cool, okay. The first way to think about this is to hop into the SALT source code and start to look at directories, right? That's one of the ways that we've laid this out, is that for the major pluggable subsystems, they correspond more or less to directories inside of here, right? For example, there's a cache subsystem, right? There is a engines subsystem, right? Outputters, for example, right? Proxies, queues, renderers, returners, execution modules, states, on and on and on and on and on and on, right? And so you might ask yourself, how does all of this get tied together in SALT core? And I did promise you a tour through sort of the user space, as it were, lesser known parts of SALT. But I think it's important to start right at the center of SALT's architecture. So if you want to take a journey to the center of the earth of SALT, the place that you want to go is a file called loader.py, okay? If you pull up loader.py, and the first time you do this, you will be much afeared because there is some relatively dense code in here. But if you really want to expand your knowledge of the SALT philosophy and how SALT operates architecturally, I would advise you to spend a couple of hours trying to understand, at least on a moderately high level, what's happening inside the loader, okay? You might ask yourself, for example, okay, I've seen inside execution modules this thing called dunder salt, right? And this is not really super Pythonic because it's just kind of appearing out of the thin air, and it's been injected into my namespace magically, right? And I can access it even though no Pythonisms happened, like an import of this thing, right? That's all happening via the loader, okay? If we go down here, we can start to look at some of these subsystems being loaded through very, very simple functions, okay? So the first thing I want to teach you as a takeaway is that the loader itself is actually incredibly easy to plug into, right? Once you get this concept in your head, it shouldn't take you more than 10 or 15 minutes, even with a moderate amount of knowledge, to write and provision an entirely new subsystem into SALT, right? I swear to God, this is actually so much easier than you think. Okay, let's look at the main event, right? Which is minion mods, right? This is the function that loads the execution modules themselves, okay? As you can see, this is actually really straightforward. This takes a couple more arguments than are truly necessary. But in fact, the only one here that you actually have to pass in is a copy of ops, right? Now, here's a trick. And this is a trick. Okay, let's make sure I can actually. Okay, good. What do I want to do? Okay. 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 So 2 lines there, right? Import salt.config and salt.config config.default minion ops, right? This will give you the default minion options dictionary, okay? This actually corresponds to the options which would be available to you in /etc/salt/minion if you're a Unix or Linux user. It's a large dictionary that's representative of the various config options that are available to you. So anytime you see ops and you want to see a copy of what that is by default, you can just do this, especially if you want to play around on the command line. So let's say we did something like this, right? Ooh, whoa, not like that. That's embarrassing. How about this? Okay. And now we import salt.loader, right? And we call salt.loader. Okay, actually, let's do this so I can sort of show you on both sides of this. Okay. Dun, 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 dun. Minion, okay. Ah. Come on, Tmux. Okay. Salt.loader.minion mods, right? That is, in fact, a copy of all of the Salt execution modules loaded immediately for you in basically 3 lines of code, okay? Super easy. If you, and this is a paradigm that you can use all over the place. So actually, if you did this, right, all right, and you did, all right, something like this, right? Hey, look at that. It's an actual function, right? So that proves to you that this is, in fact, direct access into the function itself that corresponds, of course, to, pardon me, I'm now in the modules directory, right, to command raw, right, right? That is, in fact, this function here. Okay? But back to the main point, right, which is the fact that it's extremely easy to be able to extend the loader system. All you would need to do if you wanted to build a new subsystem for Salt, the steps would be create a new directory, right? My new foo, right? Go in there, make yourself a dunder init. I won't do it, right, because we've got other things to do, right? And then go into the loader, right? And you can basically just kind of cargo cult another one of these that's really easy, all right? So you would do something like, all right, def my new foo, right? Take a copy of ops like this, and then you would return something called a lazy loader object. This is something that we return from the loader so that we can lazily load all of the modules, which is a substantial performance improvement. And then all we would have to do is basically copy this exact syntax, right? Module dir, right? We would give it the name of our new directory. We would pass in ops. We would give it a tag so that we could separate the namespaces internally. And the last thing to realize about how to use the loader in this way is we have this concept called pack, right? I talked earlier about how it feels a little bit magic, how things like dunder salt get inserted into like the operational context of a specific module. Pack is what handles that magic. So if you passed, obviously you pass ops in here, right? And so if you have that copy of ops, that means for every module that gets loaded in your new subsystem, you will have a special dunder there available to you. And that could be ops, that could be a copy of dunder salt, right? That copy of dunder salt, right, would be this lazy loader that we loaded up here, for example, right? Or whatever you want. And that's really, at that point, you're off to the races. You can start using this new subsystem that you've created inside engines or beacons or anywhere that you want to load it. You could modify the loader so that execution modules had your new subsystem packed into it, so on and so forth. So there's a lot of exciting possibilities if you just take 15 minutes to understand how the loader operates, right? I think I'll take questions sequentially. So are there any questions about how the loader operates? I mean, not any, it's complex, but no? Okay, you can find me later, or you can find, go quiz one of the core engineers who they're supposed to know all this, and they do. Okay, the next thing that I want to talk about in terms of relatively unused, or I guess a better way to say it would be unappreciated subsystems in SALT, is the one that I love by far the most, and not never, but too rarely hear people talking about it, which is the concept of SALT engines, right? Who here runs a SALT engine in their production infrastructure? Oh, see, my heart, right? Okay. So I suspect that means that not everybody in here knows what a SALT engine is. So let me give you a brief description, right? And you're really going to want to tuck this in your head, because once you get this, you're going to see SALT, I think, in a really dramatically different way, okay? An engine is an arbitrary Python process, okay, which can run adjacent to either a master or a minion. And most importantly, this arbitrary Python process can have access to special dunder dictionaries given to it by the loader, okay? That's kind of a dense description, so let's unpack it a little bit. What this means is that you can write pure Python, okay, that will run on a master and have immediate access to all of the runners on that master, right? It will have immediate access to the master event bus, right? It can execute jobs. It can listen to events that are happening. The possibilities are endless. And here's why I think this is important, right? Because I think at the end of the day, it's really interesting to reimagine SALT not just as this management framework that you can run at scale to do things to many machines, but it has a lot of interesting possibilities when you think about SALT, in fact, as an application level driver, right? There's no reason at all that you can't write, for example, a tiny little REST web server, right, into a SALT master that doesn't run as root, it lives somewhere, right? And you get all the advantages of something like this robust event bus, right? All the advantages of being able to manipulate certain areas of a system, right? And all you're doing is writing pure Python, right? If your light bulb starts to go off there, right, you can start to think about SALT, I think, in a fundamentally new way. Let's look at how you deal with engines, right? So I'm really pleased that I asked. So, not that many people have dealt with this. The one that most people look at most often, right, is something like the Slack engine that I think Gareth worked on a bunch. Yeah, Gareth Greenway back there. Did you write this initially? Yeah, so okay. So I'm going to tour Gareth's code, so that's exciting for Gareth, right? And see you, Gareth. Okay. So the important thing to remember about SALT engines really is that they are designed to be long-running processes, right? They start when the master starts, they start when the minion starts, right? And then they just keep going. How do they keep going? There's a single defined entry point. That entry point is called start, right? Okay. It can take some arguments if you like, but then it just continually goes through and runs and does things, right? Here, the Slack engine, right, can listen to events that come in, right, potentially match against them, if I remember correctly, and then perform actions, right? And that's how you can get away from this paradigm of SALT simply being a manual command and control paradigm, right? So a brief rant. I think for a long time, we've seen automation as sort of being this function of configuration management, right? Of simply modifying the states of systems, right, in a stepwise fashion, right? Either taking an image, right, that is in some known state, like a stock OS image, right, and deciding that we're going to provision it to some other known state. Or a security update comes in, right, and then we go, okay, we've got to roll this update out to a bunch of minions, yada, 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 type in some commands, write some states, right, off to the races, and then, hey, 10,000, machines change, and hooray, we can all go home. That's fine. I mean, I think that's really nice. But at the end of the day, that doesn't really feel that much like automation, at least to me, right? I think real automation, or what the future of real automation has to look like, is the ability to be able to listen to and react to changes in the system in real time, right? In that way, we cannot just write these prescriptive workflows, right? But we can, in fact, write reactive paradigms, right? Where, again, as the system is modified, right, we modify it according to rules that we set out. And if that's something that you're interested in, engines are the first place to start to engage with that. Like you can see, Salt ships with quite a number of engines, right out of the gate, so you can play with those. If you write a generic engine that you think is of use and you wish to upstream it to us, we would very much love to have it. Question?
Are all these engines starting when
No, they, yes, thank you for pointing that out. You have to set them up in the config, right? So you say something, there's like a little bit of YAML, it's like engines and then a list of engines. And then if you want to send that engine a set of parameters that correspond to what's in the arg spec, right, for the start function that you're looking at, then you define those there, right? Does that all make sense? Cool. Any other questions about how engines operate? Yes, no? Okay, how are we doing on time? Cool. Okay, so that's engines. The next thing that I want to look at, right, are beacons, right? How many people run beacons in their production infrastructure? 1, 2, okay, all right, good. So this is an important thing to cover too. And then we'll get into more specifics. Beacons, for those who aren't aware, right, are Python processes executed by a Salt minion on a short loop on a regular interval that can check for some sort of state change on a system. If it detects that state change, it fires an event up to a master. So the traditional paradigm with beacons is to connect what's happening in a beacon to a reactor on a master, right? So like the classical example that we always give, for example, there's one beacon that we have here that deals with changes to files, right? If a file changes, then fire this event up to the master. There's a beacon example, for example, for load, right? So if load exceeds some certain threshold, fire an event up to the master. You can use these beacons in tandem with the reactor to be able to come up with really straightforward, easy to reason about reactions, right? So if you're looking for the path toward event-driven infrastructure, start to think about this beacon reactor paradigm. Now, we were going to look at specific things, right? Oops, wrong window. Okay. So, how to write beacons, right? So easy, right? You need to write a function. Your function should be called start, all right? If you have a function called start, right, you do that, and then inside that function, basically you do like a little while true, right, and let it loop, right? And that is it, right? Okay. right? So if you look at let's look at the test beacon, for example, right? So this beacon starts up, right? It connects to the event bus, okay? For those who aren't familiar, right, a lot of times you hear us talking, kind of this big talk about an event bus, right? And you're like, yeah, things are flying around, but how do I actually use it day to day, right? Your secret to that is right here, right? Salt.utils.event.getEvent, right? If you just remember that, that's really all you need now that you know what ops are, right? And typically ops are available, again, in engines and execution modules in the Dunder ops dictionary. If you remember salt.utils.event.get_event, right? You pass it what it needs, and it returns to you a connection to the event bus, and you're off to the races. At that point, you can start pulling events off the bus, you can start pushing them onto the bus. All of that functionality is described in the salt.utils.event class, or module, and then there's a class inside there, right? You can see here, this is doing that exact thing, right? So this is like the simplest example of how do I use the event bus directly. Obviously here this is in a beacon, right? What you do is you get yourself an event bus instance and then you call getEvent, right? If there is an event on that bus that you have not heard, you will hear it, right? It will be there in event. You dump that event, right? And then if there is an event, this just logs it, right? So this is a very simple beacon, right? Every time it runs, if there's an event on the bus, right, that it hasn't heard, it will log it to the debug log. Simple, right? Cool. Any questions about how beacons work or why they would be interesting or important in your workflow? Yes, sir?
I see some engines that fire events on the bus versus beacons sometimes.
Yeah.
Is there a difference as far as what you prefer to use, or does it not matter? Do engines have more capability versus beacons?
Engines are free form, right? So it's free form Python. Typically, the use case for an engine is to connect to an event bus and listen for something or do something, right? Beacons are designed to not block, right? To be short, quick bursts of state change, right? So they're more narrowly prescribed in terms of their usage, right? Where engines are, the Wild West, right? Just go nuts, right? You need to write, a single function entry point, and then whatever your use case is, go to town, right? Does that make sense?
Yep.
Cool. Yeah. Yeah, please.
Why is the test beacon in the engine folder?
Is that the engine folder? Yeah. I was looking at an engine this time. That makes more sense because I was like, why is that looping? And I was like, yeah, it's like, okay, that makes more sense. Thank you. Yeah. This is a branch off of develop from this morning when I thought I could rewrite the loader during a talk. SaltUtils has a Dunder init, which has grown a little bit weighty over the years, and that part is being broken apart. Salt.utils.event has not changed. Yeah. Forgive me for the mistake there and getting confused between my examples. Let's actually, all right, now that we're in a beacon, let's show a proper example. Let me pick a good one. How about ps.py? Right. Okay. This makes more sense. Right. Beacons have a validate function, right, which will take in the config that's declared in the configuration file and ensure that it's correct. Thanks to our friend Gareth. Right. And here's your beacon. Right. You get one function, right, called beacon, right, inside there, right. It takes a config. The config, right, is just going to be a dictionary, right, that is defined in the configuration itself, right. And then it will do things, and then it will return, right. The watchword with beacons is to make sure that you're not doing anything really heavy, right? Like this is not the place to traverse an entire file system, right? You want to do something really lightweight and return quickly because your next iteration is coming around at you really, really quickly. Yeah, Colton?
I want to hit that even harder.
Yeah.
The beacons execute in the main minion process. So if you block for any amount of time, your minions become
Yeah.
So you need to be quick.
Right. Yeah.
Why beacons are told to disable while states are running.
There are people that have run into that. Yeah. Yes. Yeah. The question is, some people have dealt with an issue where they've had to disable beacons while states are running. Right. Yeah. Other questions? Cool. Okay. So 216. All right. Yeah, please.
If you have a process, normally you want to put the beacon when it blocks and it's really slow. Would it be appropriate to pull it out from the main engine because it then runs in a separate
Absolutely.
process?
Yes. Yes. That is exactly the right reaction to that problem. Yeah. Other questions or concerns? Things of that nature? No? Okay. Cool. All right. And let's see, we're at quarter after. We end at half past, yes? Great, thank you. Okay. So I want to run you through a couple of other areas that are not looked at that much, but I think are really, really interesting and really valuable. The first is in here, right? If I want to show you SDB, right? Does anybody use SDB in production? A couple people, okay? This comes to us from our friend Joseph Hall, right? Yes, we see you, Joseph. SDB is a really lightweight data storage mechanism that you can use. So a lot of times, not a lot of times, but from time to time, you may be writing a state or you may be writing a module, and you may think to yourself, a really classic case is, man, I wish I had something from Salt that I could temporarily store the state of this so that I could come back and refer to it the next time around, right? You know? So maybe, for example, like the last time this was run, or whatever the result was, right? And for whatever reason, the minion cache isn't the way you want to do this. SDB is something that's available to you to do something like that. The other thing that SDB can do is that it can actually use that storage, and you can pull from it to inside your master minion configs, as I recall. Yes, yeah. And so to access SDB, there is an execution module to do it, right? It's right here. It's incredibly simple. There are getters and setters, and then you are off to the races. If you look here, right? Right. This is how SDB, if you look in the documentation, has a series of backends. And in fact, it should come as no surprise to you that SDB is in fact a pluggable system, right? So if you want to use Vault as your backend, even if you want to use something like a REST endpoint as your backend, which is kind of wild, but if that's your thing, console, CouchDB, yada, yada, yada. The simplest way to do this is to use SQLite, right? And so you can see here, this is actually, right, the implementation for that describes how to use all of that. It requires, right, that, yep. So basically you need to make sure that SQLite is available to your Python binary. And then you just configure it as such over here, right? You give it a driver, you give it a database name, you give it a table, and then you're off to the races. So again, if you have a need for that sort of statefulness between runs, right? Or between state runs, between module executions, you can look to something like SDB to solve that problem for you. Questions about SDB? It's incredibly straightforward. Yeah, please.
I have a broader question about engines and beacons and SDB.
Okay.
So if you're running an engine, for example,
Yeah.
where should that live in your code world, right?
Oh, in your deployment?
Yeah.
Yeah, you can put engines, as I recall, and I'm pretty sure this is true, so we'll check after this, in serve salt _engines, right? I'm fairly sure that's correct, right? Yeah. And same goes for beacons and right, everything else, right? Yeah. Cool. Other questions? Yeah.
What would be the difference in a use case to just modify a custom grain dictionary as opposed to
It really depends. I mean, in terms of like local storage, that might be right. Perhaps if you're using something like Vault, right, you want other systems perhaps to be able to query that. And so SDB could serve that purpose potentially. Joseph?
SDB was created
Yeah.
in order to secure cloud passwords for SaltCloud.
Hmm.
And it was just made to be usable in the rest of SaltCloud.
Yeah, right. Cool. Thanks, Joseph. Yeah, so I'm a big fan of SDB. The other thing which is sort of ancillary to that people aren't aware of very much unless they do a bunch of Salt-specific development. Has anybody written states and used Dunder context? No one at all. Yes, one person. All right, you're the man. Dunder context is extremely handy. I don't have like a really great example, but let me just describe it so you can understand its availability. Dunder context is a special Dunder which is available inside of state modules, right? It is by default an empty dictionary. But what it can be used for is to store and track contextual information between states as they run, right? In an high state run, right? So if you find yourself needing this problem, a lot of times people solve this in really ugly, gnarly ways, right? Like they're reaching out to external systems or they're like writing to disk or doing all kinds of ungodly things. You can use, just reach to Dunder context, right? And understand it's just a native Python dictionary and just start slamming data in there. So start using it as a key value store. If you want to see examples of how this is used, I think elegantly, take a look at the package states inside Salt, which is the place that we use it most often, right? Because that gives us performance advantages, right? Eric, I'm sure, can speak to those because he's done that a bunch, right? But it, also true, yeah, thank you. It can. Oh, sorry. So what Eric said was that Dunder context is available in execution modules as well as states, right? Oh, that was the question that you actually had. Okay, cool. Right. So we have just a couple of minutes before we wrap up. Does anybody have any other questions about anything we've covered or anything else, or questions, just general like Salt ecosystem questions? Yeah, go ahead. Yeah. Yeah.
So, can I get a subsystem and put somewhere else outside the source?
Right. Yeah. Right. You see how I'm in this auto load branch right now? This is something I've been thinking a lot about this week, as though I don't have enough to think about this week. I think this is actually possible to do, to modify the loader so that we can turn it into an autoloader, so that all you would have to do would be to drop in a new directory, right, somewhere, and then define that in your configuration, and the loader will just automatically know about it. So if there are people here who are interested in working on that and trying to solve that and want to hack on that today, and like maybe we can get it done by the party or something, come find me and we'll put together a little hackathon and see if we can get that done. But I totally think that's possible, and I think it would be really cool. Yeah. Okay, it doesn't look like there are any other questions, so if you do have questions, please come and find me, and I will be happy to help, or find any number of the core engineers who know considerably more about this stuff than I do, and make sure you ask them extremely difficult questions. Thanks very much. Have a wonderful conference.